I don't know about you, but I've heard my whole life that the glass of windows or bottles is made from sand. I get the impression that you could go to any beach, grab a handful of sand, melt it, and get perfectly transparent glass. However, if you try to do that, what's most likely to happen is something like this. The only thing you achieve is slightly lightening the color of the sand and producing tiny glass beads. If the experiment doesn't work, why is it said that glass is made from sand? It's time to clear up the doubts. Glass is manufactured by mixing and melting different powdered chemical compounds, but the main ingredient is silicon dioxide. This name sounds familiar because silicon dioxide is the substance that composes that well-known and abundant mineral called quartz. What differentiates glass from quartz is the way the oxygen and silicon atoms are arranged in each material. In quartz, they follow a regular pattern, while glass is characterized precisely because they are disordered. Additionally, it has been said that sand is made of quartz, or rather grains of quartz. Therefore, one could imagine that the idea that glass is made by melting sand comes from associating these two concepts. However, this idea is wrong, because things are not that simple, and both sand and glass are more complex substances than they seem. Let's start with sand. We all know that sand is made of crushed rock, but not all rocks contain quartz, and those that do usually also contain other minerals. Therefore, the sand that forms from the grinding of these rocks is usually a mixture of several different minerals. The easiest way to get an idea of what mineral sand contains is simply by looking at it. Pure quartz is white in color, so sand that only contains quartz grains will be completely white. Now, how many completely white beaches or dunes have you seen in your life? Very few, because although it's true that there are places where the sand is made almost exclusively of quartz, most of the time it's a jumble of many different minerals. A clear example is the black sand of volcanic beaches. Under a microscope, you would see that most of the grains of this sand are pieces of a volcanic rock called basalt, which has a dark color. Although you can also distinguish an occasional crystal of olivine, a very common mineral in this type of rock, whose hue ranges from green to yellowish, depending on how worn down it is. Furthermore, there are volcanic beaches where the sand is greenish instead of black, precisely because it contains a very high proportion of olivine grains. Other minerals tint the sand with more exotic colors, for example, in the crater of an extinct volcano called Lazo, and in some spots on the terrain, such a quantity of tiny grains produce sand that has a red or purple color. This same color of sand can also occur on beaches, either because the original rock also contained grains, or due to the presence of pieces of lilac or pinkish shells. The closest thing to pure quartz sand would be a sample of desert sand, completely from the Sahara Desert in the part of Libya. However, as can be deduced from its brown color, the quartz grains that make up this sand still have many impurities. Under the microscope, you can see that this sand is made solely of rounded quartz grains eroded by wind. However, although it is translucent quartz, its color is yellowish or brown because it contains iron impurities. And what about the sand that was collected at the beginning and used in an attempt to make glass? Well, the gray color of this sand already indicates that it's not made only of quartz, but also in Ibiza, an island that is mainly composed of limestone. The limestone is made of calcite, a mineral that is made of calcium carbonate, not silicon dioxide. Furthermore, looking at this sand under the microscope, you can see that the grains that are most abundant by far are white, smooth, and opaque. These grains are pieces of calcite, the mineral that composes limestone. Among those white grains, there are also a few black fragments that could be hematite, magnetite, or goethite, some iron oxides that are also quite abundant in the rocks of the area. However, not many quartz grain indications can be seen. Still, there was curiosity to know if there was any quartz in this sand. So 30 grams were introduced into a beaker, and hydrochloric acid was added. The idea was that the acid would convert the calcium carbonate and iron oxides into calcium chloride and iron chloride, salts that would dissolve in water. On the other hand, the acid would not react with quartz because silicon dioxide is a very inert substance, so any trace of quartz that was in the sand would remain intact. By the way, a side note, since ocean water is slightly acidic, this same process also occurs in nature in slow motion. The water gradually dissolves minerals, such as carbonates and iron oxides, and the quartz concentration in the sand increases over time. This is the reason why, in general, a beach that is formed from carbonate sand has formed more recently than another that is made mainly of quartz, although of course the original composition of the beach also influences this. End of side note. When the reaction was finished, the acid had dissolved more than 29 grams of sand and only less than 1 gram of insoluble substances, such as quartz, remained. In other words, the beach sand is made almost entirely of carbonates and iron oxides. If you take a look at those insoluble remains under the microscope, you can see two types of angular grains, some lighter and some darker. The white and transparent grains are quartz, no doubt, while the darker and translucent ones are probably also quartz but darkened by iron oxide. In any case, it cannot be ruled out that the blackest and most opaque ones are insoluble manganese oxides, or even iron oxides that didn't have time to dissolve. To finish, interestingly, among these minerals there are also some transparent grains of more varied colors. Given the geological context of the area, this cannot be olivine or other exotic minerals, so they must be simple pieces of colored glass from eroded bottles. In any case, based on this test, it can be concluded that the sand is made almost entirely of carbonates and iron oxides, and contains very, very little quartz. The moral of this experiment is that the idea that sand is made of quartz is a very crude oversimplification. It is true that there are areas of the world where the sand is made almost exclusively of quartz, and in some places that sand is even extracted for use in industry. But most of the time, the sand contains many different minerals in different proportions, depending on the geology of the rocks in the area. With all this in mind, why wasn't glass successfully manufactured with the sand collected at the beginning? Well, because glass is made of roughly 75% silicon dioxide, quartz, 15% sodium carbonate, and 10% calcium oxide. Therefore, it's not surprising that this sand didn't melt and form glass because it's made of about 97% calcium carbonate and iron oxides, and it contains very, very little silicon dioxide. In fact, the microscope can be used to compare how the sand looked before and after heating it. One of the things that stands out the most is that the calcite grains have become whitened and lost their shine, although it's not certain why this has occurred. It could be assumed that the reason is that the calcium carbonate on the surface of the calcite has decomposed and formed calcium oxide. Additionally, to see if the little quartz that the sand contained had managed to melt, the sample was treated with acid again to get rid of the oxides and carbonates. As you can see, the quartz grains that did not dissolve are now much more transparent and rounded than before, and are full of bubbles. This indicates that the quartz did melt, but there wasn't enough of it in the sand for the melted grains to join together and form a larger mass of glass. In other words, the glass of bottles and windows is not made by melting sand from any beach, but rather by melting a mixture of silicon dioxide, quartz, along with other chemical compounds in very specific proportions. The function of these chemical compounds is to lower the melting point of the mixture, increase the corrosion resistance of the glass, reduce its coefficient of thermal expansion, or eliminate bubbles, to give a few examples. Of course, most of these chemical compounds are not even present naturally in beach sand, much less in the right proportions. So, even if pure quartz sand is found, those other substances will have to be added separately in order to achieve a glass that is halfway decent. At this point, there was a desire to melt several sand samples with different proportions of quartz and other minerals to show the kind of opaque, low-quality glass that would result, but as mentioned, in Ibiza, an island made of limestone, there's not much variety of sands available. However, thanks to a passion for meteorites, there is something much better to show: samples of imperfect glass that formed completely naturally. These are tektites, or in other words, pieces of natural glass that form when a meteorite collides with the Earth with enough force for the ground material to melt and disperse into the air. During their journey through the atmosphere, this melted material cools rapidly and solidifies, and if it contains enough quartz, it becomes a glass that is able to remain unaltered for millions of years. Tektites come in different colors, shapes, and sizes. For example, an Indochinite, a type of tektite that formed 700,000 years ago in the present-day Indochina region. It is black and completely opaque. In the Atacama Desert, similar opaque and dark tektites called atacamites were found. These atacamites are especially curious because many of them preserve the elongated shape they adopted while molten and flying through the air. That said, the atacamite fragment that was most exciting to find was this one that is not only translucent, but contains air bubbles inside. However, not all tektites are black and opaque. For example, a moldavite, a type of green tektite that formed in the present-day Czech Republic 15 million years ago. This glass mass is much more transparent than the indochinites or atacamites. Additionally, the direction in which the glass flowed while molten was marked on its surface. Probably the closest thing to transparent artificial glass that can be found in nature is what they call Libyan Desert Glass. These tektites formed 28.5 million years ago from the same material that gave rise to the Saharan sand, although they also usually contain fragments of opaque material that did not melt during the impact. In the case of Libyan Desert Glass, it is especially curious because it has been used since antiquity to make jewelry. An example is the scarab from a necklace that belonged to the pharaoh Tutankhamun. The black-green or yellowish color of tektites results from the presence of iron impurities. The ones that contain more iron are darker and more opaque, and among those that contain less, the color depends on the oxidation state of this element. Those with a brown or yellow color contain a higher proportion of trivalent iron, while the greener ones possess more divalent iron. In any case, tektites give an idea of the appearance of glass when it forms from any sand or rocks. But the moral of all this is that, although technically something more or less similar to window or bottle glass could be produced if a very specific type of sand with a lot of quartz were found and melted, most of the time an attempt is made, disappointment will result. And so our journey through the world of glass and sand concludes. But before we say goodbye, have you ever wondered what rare elements could be limiting life in the universe? If curiosity gets the better of you, I invite you to browse through our playlist and discover new wonders. We'll see you in that corner of the cosmos full of mysteries. Until next time.